So friends, we'll be starting a new chapter today. It's fixed income risk and returns. So we'll have to learn about the risks associated with investing in a bond, the returns associated with it, the different kinds of durations that are associated with it. So let's get on with it. So what are the sources of an income of a person who has invested in a fixed income instrument? The first source is of course the coupons. The regular coupons that are received from the bond at the relevant periodicity is basically the first source of income. Then there is reinvestment income. So these coupons are reinvested and they earn some return. That return is basically this reinvestment return. And the third return is if somebody sells it at a higher price, then there is capital gains. Now what are the dynamics of the capital gains, reinvestment returns and the coupons? Let's understand through some examples. Let's say a bond has 5 years to maturity. Let's say there is a bond with a maturity of 5 years. The coupon is 10% and currently it is trading at 85% of par or 85. Now in the first case, case 1, we take the yield at 9%. Now based on this, we will try to understand what is the return of an investor who holds this bond till maturity. Okay. Now let's first calculate the reinvestment returns. This coupon is received at t is equal to 1. Therefore, it can compound 1, 2, 3, 4 times. So 10 into 1.09 to the power 4 plus this coupon 3 times. So 10 into 1.09 to the power 3 plus this one 2 times. 10 into 1.09 to the power 2. This is 1 times. 10 into 1.09 to the power 1. And this one will be received at the ultimate period. So this is 10. Now at the ultimate period, say the maturity amount received is at par. So this is 100. Now we come back to the calculation. This comes to be 10 into 1.09 to the power 4 is equal to 14.1158 plus 1.09 cube into 10, this is 12.95. 1.09 square into 10, this is 11.88 plus 1.09 into 10, this is 10.9 plus 10. So if you add them up, it comes to be 14.1158 plus 12.95 plus 11.88 plus 10.9 plus 10. The total comes to be 59.8458 approximately. Now the maturity amount is 100, right? Therefore, the person has paid 85 and his total return is 100 plus 59.8458. Therefore, the return to the person is, let's say the return is R. This is for how long? This is for 5 years, right? He invested at t is equal to 0. Therefore, this is 1, 2, 3, 4, 5. So the compounded return comes to be expressed by this equation, where R is the return to the investor. Let's calculate this, guys. This is equal to 159.8458 by 1 plus R to the power 5. So the final answer here comes to be 159.8458 divided by 85 to the power 1 by 5. This comes to be 13.46%. So R here comes to be 13.46%. Case 2 is a case where bond is sold at t is equal to 2. Now what is the price at t is equal to 2? Let's first understand that. The bond price is basically the present value of the future cash flows. So what are the cash flows? Let's calculate, guys. At t is equal to 3 there is a cash flow 10. At t is equal to 4 there is another cash flow of 10. At t is equal to 5 there is another cash flow of 110. Now this gets divided by 1.09 cube. This gets divided by 1.09 square. This gets divided by 1.09, right? So the present value becomes, let's calculate, guys. 10 divided by 1.09, this is 9.1741 plus 1.09 square inverse into 10, 8.4168 plus 84.94. So you add them up. The present value is 102.5309. This is present value at t is equal to 2. Now let us look at the reinvestment returns at t is equal to 2. So if you look at the coupon received at t is equal to 1 and t is equal to 2, you will see there is the coupon at t is equal to 1 compounds once, and the ultimate payment received is the coupon at t is equal to 2. So the reinvestment return is easy to calculate. One coupon compounds for one period and the next coupon is received at the time of sale, say. So this becomes 10.9 plus 10. So this is 20.9. Now the total return becomes 102.5309 plus 20.9. This is equal to 123.4309. 123.4309. Okay, this is the total return. Now the compounded return to the investor we can calculate easily. This is 85 is equal to 123.4309 divided by 1 plus r to the power 2. This implies r is equal to root over of 123.4309 divided by 85, this minus 1. So this comes to be 20.5%. So in the previous case the return was 13 point something, here the return is 20.5%. Okay. Now we will look at case 5. This is an example where the yield right after the purchase at t is equal to 0 drops to 8%. From 9% it drops to 8%. And the policy is hold till maturity. Now in this kind of a situation, first we measure the reinvestment returns. Obviously, we start with this one is compounded 4 times. 10 into 1.08 to the power 4 plus this next one 10 into 1.08 cube plus next one, it is 2 times 10 into 1.08 whole square plus this one, this is 10 into 1.08 plus the ultimate payment which is 10. Only the coupons we are considering here. This amounts to 58.67 approximately, right? So this is the approximate value that comes from this expression. Now we add the maturity amount to it also. The maturity amount is 100. Therefore, total amount is 158.67. Now to get the return from this, we write the equation for it. It is 85 is equal to 158.67 divided by 1 plus r to the power 5. Therefore, r can be written as 158.67 divided by 85 whole to the power 1 by 5 minus 1. Let us calculate this value, guys. This comes to be 13.29%. Now, if you remember, when the yield did not decrease or increase and the hold to maturity was the policy, the return to the investor was 13.46%. So this return is less. So from this we can conclude, when the policy is hold till maturity and the yield decreases right after the purchase, the investor's returns are hampered. So in a hold till maturity policy, the investor's returns are hampered by decrease in yield. Now we would also like to check what happens if there is a decrease in yield and the person sells early, say at t is equal to 2. Now we take a case 6 where there is a decrease in yield, that is the yield comes down to 8%, but the person does not hold till maturity. He or she sells at t is equal to 2. So case 6, yield goes down to 8%, but person sells at t is equal to 2. The first thing we measure is what is the price at which the bond is sold. Now here there are 3 cash flows, right? This is again present value of the future cash flows. So there is a cash flow of 10, there is another cash flow of 10, and there is an ultimate cash flow of 110, right? So we just discount them to the present value, or the t is equal to 2. So this is 1.08, this is 1.08 squared, this is 1.08 cube and the sum of this is the present value at t is equal to 2. This comes to be 9.259 plus 8.573 plus 87.32. If you sum it up, it comes to be 105.1535 approximately. Therefore, the total amount is 105.1535 plus, now we calculate the reinvestment returns. So the reinvestment return is 10 into 1.08 plus 10, because at t is equal to 2 this 10 is received, and at t is equal to 1 this 10 is received, which compounds for 1 period. So this is the reinvestment return. This comes to be 10.8 plus 10, which is 20.8. Therefore, total amount is 125.9535. This comes from adding 20.8 with 105.135. So here r is given by 85 is equal to 125.9535 by 1 plus r whole square. Therefore, r is given by root of 125.9535 by 85, this minus 1. R comes to be 21.729% or 21.73% to be exact. Now if you remember, in the case where yield did not change and the policy was sell at t is equal to 2, the return to the investor was 20.5%. So this return is greater, right? So we can write the postulate: when the yield decreases and the investor sells before maturity, the returns are enhanced. When the yield decreases and the investor sells before maturity, the return to the investor is enhanced. Now we'll learn about something called duration.